Here we are with a 5-minute math lesson. The topic is math skills. This is section 1.1a of the 5-minute math series. Today, I'll be talking about how to convert decimal numbers to scientific notation. Scientific notation is needed to make very big numbers and very small numbers faster and easier to write. Now, some of the numbers that we use in science have names. This number, 602 with a whole bunch of zeros following, is called Avogadro's number. And this number is very important in chemistry. So we don't want to be writing this giant number on our papers. We want a faster, easier way to indicate this specific number. So this is what you do. First, you locate the decimal point. Well, I don't see any decimal point, so that means it would be right here. All right, so there's the decimal point. Now, for a very big number, you have to move the decimal point to the left because you want only one number to end up in front of the decimal point. Let me show you. We're going to jump and count how many places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 jumps to make sure that we have moved the decimal point so only one number is in front of the decimal point. So we've got 6.02. And how many jumps was that? I think it was 23. 10 to the 23rd. 23 jumps, only one number in front of the decimal point. We have just converted Avogadro's number. This is the decimal form. This is correct scientific notation. Here we have a very, very small number, 0.0000, etc., 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 667. This number is used in physics, and the name of this number is the universal gravitational constant. You can look on your physics reference tables and find this number on the front page. Now, to convert this number to proper scientific notation, we follow the same rule that we just applied to Avogadro's number. We find the decimal point, and we move the decimal point one jump at a time, counting the jumps until the decimal point has only one number in front of it. Here we go. Jumps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 jumps. If you put the decimal point there, now there's only one number in front of the decimal point. The zeros don't count. All right, so 6.67 times 10 to the negative 11. When a number is in proper scientific notation, there's only one number in front of the decimal point. Now, this entire number in front of the multiplication sign is called the mantissa, or the coefficient. So 3.82 here is the mantissa, or coefficient. Over here, we have the exponent, or order of magnitude. You can think of it as 5 or 10 to the 5th. The exponent, or order of magnitude. Let's convert these decimal numbers to scientific notation for practice. Here we go. First, find the decimal. This is the number 4,000, so the decimal has to be right there. Now we're going to jump the decimal, so there's only one number in front of the decimal. That means, I get rid of that comma, it's just in the way. That means that this decimal is going to end up over here. Let's start jumping. Count the jumps. 1, 2, 3 jumps. So this number is 4 times 10 to the 3 jumps. We have here the number 62. That means the decimal is right there. We want the decimal to end up over there. So that's going to be one jump. 6.2 times 10 to the first. All right, here we go. 3,080,000. So the decimal point is obviously over there. We want the decimal point to end up over here. Let's start jumping. 1, 2, 3, 4, 5, 6 jumps. 3.08 times 10 to the sixth. All right, so these were big numbers, so all these exponents end up being positive exponents. Now here we have small numbers. I want you to keep in mind these zeros in front are not important. It doesn't matter whether those zeros are there or not there. The number does not change. All right, here we go. Here's the decimal point. We want it to be here. So there's only one number in front of the decimal. Here we go. 1, 2, 3. This was a small number, so that's 5 times 10 to the negative third. Small numbers get negative exponents. Here, we're going to jump once. So it's 2.4 times 10 to the 1 negative jump. All right, and finally here, all right, we have 1, 2, 3, 4, 5 jumps. All right, so this is going to be 8.9. They must have put that 0 there for a reason. Let's stick it in there. Times 10 to the negative 5. Okay, so this is how you convert decimal numbers to proper scientific notation. In proper scientific notation, there can only be one number in front of the decimal point. If it's a large number, it becomes a positive exponent. A small number, point whatever, becomes a negative exponent.